Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at now categorized questions under organic chemistry, right? So I'm going to start with the nomenclature ones. Then when I start here, it is now physical property. Then when I reach here, let me see. Yes, when I reach here, it is organic reactions. Okay. Yes. So yeah, let's just dive into it. Which one of the following below represents an alkane? Remember, an alkane has a formula of, has a general formula of CnH2n plus 2. So it means now, when I look at A no, why A it is an alkane, it has a general formula of CnH2n. If I have, for every one of n, I have twice of that. Can you see? 1:2. Then here, 1430. 1430, let's see. If I have 14 of those, according to this formula, if I have 14 of those, I need double of this, double of that for carbon. For hydrogen, I need double of that, which is 28 plus 2. Therefore, it gives me 30. So this one, it is 30. This one looks to me very correct. This one looks to me very, very correct. Let's look at number B. C5H10, no, this is an alkene. C8H14. Okay, this is an alkyne. Why? Because now, can you see, if I have 8 here, I need double, which is 16 plus 2, then I need 20. Can you see this one is not it? So this is an alkyne. So the most correct answer is B. Consider the following compound, okay? CH blah, blah, blah. So here I have 1, 2, 3, 4. When I name this, it's going to be 2.2, so 2.2 dimethyl what? 1, 2, 3, 4 butane. Okay. They say the IUPAC name of the compound, it is what? Now we have already written it. 2.3, no. 2.2, yes. Dimethyl butane, very, very good. 3.3, it is incorrect because now you need to prioritize where now you give the substituent or the branch the possible smallest number. Okay? Yes. Very, very good. Remember this, it is not a branch. This is not a branch. It is part of the longest chain. You can do it like this. You will see that it is not a branch. How interesting is that? Then, this is also incorrect. 4.5, 45. Which one of the following is a secondary alcohol? A secondary alcohol, we need to see the carbon bonded to the OH, bonded to 2 other carbons, right? So which one is that? Ethanol. Ethanol is just a straight chain like this, like this. It is a primary alcohol, okay? No. Butane 2-ol. Sorry, butane 2-ol. Butane 1, 2, 3, 4. And carbon number 2, I have an alcohol. 1, 2. Then can you see the carbon bonded to the hydroxyl group here, which I refer to as the king, is bonded to this one and this one. So it is 2. So now the most correct answer for me, it is number C. Let's look at butane 1-ol. Butane 1-ol, it is 1, 2, 3, 4. But OH, it is on carbon number 1. Can you see now the king, the carbon bonded to the hydroxyl, which I call the king, is bonded to 1. Can you see? So this one, no. 2-methyl butane 2-ol. Butane 1, 2, 3, 4. Then butane 1, then 2-methyl. I know. It is also a primary. Okay, yes. 46, a functional isomer of ethyl propanoate. This is an ester. So a functional isomer of an ester, it is a carboxylic acid. I'm expecting something that has COOH. And how many carbons? This one has, if it is 2, prop, it is 3. It means I need an ester. So a carboxylic acid that has what? That has 5 carbons. Something like maybe C. Okay, this one already has, it is already 5 with this one. So I need C4H. H something. Okay, so yeah, because now, okay, let me say ethyl propanoate, its functional group is going to be an ester. Okay, when I draw this, it is what? This is not an ester. Why? Because it is a H and double bond. This is an aldehyde. You can draw this. It's going to give you C4 1, 2, 3, 4 plus 5, like that. But here, this one, it is OOH. This is not a carboxylic acid. Remember, functional isomer of ester, it is carboxylic acid. When I look at number B, this is OH. This is alcohol. No. When I look at this, it is HO. This is also an aldehyde. No. When I look at this, it is COOH. It is an ester. And it has how many carbons? 4 plus 1. It is 5. Also, this one has 2 plus 3. It is 5. So the most correct answer is C. I go. It has been C. C. Which one of the following combination are both unsaturated? Unsaturated for singing. Remember, unsaturated, it is what? Alkene. Also, alkyne. So, ethane. What is ethene? Oh, okay. Ethane, it is it is an alkane, and an alkane it is saturated. So this one is wrong. Ethane and ethanol, it is saturated, it is wrong. Ethene and ethine, very, very correct. Remember, it should be an alkene and an alkyne. Ethanoic, no. B is the correct answer. Which one of the following is the general formula of alkenes? Remember, general formula of alkenes, CnH2n plus 2. Which one is that? The most correct answer is number C. In that particular case, the off. Number 49, an empirical formula. An empirical formula, do not confuse empirical formula with a molecular formula. Empirical formula shows the simplest whole number ratio. So let's start with a molecular formula of this one, hexanoic acid. So it's going to be 1, 2, 3, 4, 5, 6. It is a carboxylic acid, OH. So it will have 1, 2, 3, 4, 5, 6. It is C6H12O. O2. When you count there, you can draw this and count and count and count and count and count. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Exactly. So it's going to be C6H12O2. But now an empirical formula is the simplest whole number. This is a molecular. Okay. No, when I want now my empirical formula, it should be the simplest. I will divide by the smallest number, which is 2. It will give me C3H6O. Is there anything like that? Yes. The most correct answer is number D, the off. Okay. This one, number C, it was going to be correct if they wanted the molecular formula. Very, very good and interesting question, the off. They say, which one of the following is the correct structural formula of methyl ethanoate? Okay, methyl, it is an alcohol. This is an ester. That should look like this. Methyl, oxygen, methanoate, ethanoate, 2 carbon, like that. Let's see. This is a what? Aye. Okay, can you see? This is methyl. This, we look at the carbon. Okay, let's start here. When I start here, I have 2. This is a carboxylic acid. Can you see? It ends with a Q. This is a carboxylic acid. No. When I look at this one, this is 2 carbons from the carboxylic acid. This is what? Ethanoate. This is from an alcohol. It is methyl. Is it correct? Methyl ethanoate. Yes. So C is the most correct answer. Let's look why B is not. B tells me, okay, from a carboxylic acid, I have this one, which is methanoate. Methanoate. Okay, let me minimize this. Methanoate. And this is from the alcohol, which is what? Ethyl. So the name is incorrect. Also, this one, it is what? This and this are the same thing, was B and D are the same thing. Can you see that? Yes. To which now homologous series does a compound with molecular C4H12O2 belong? This can either be an ester or a carboxylic acid. Why? Because it has a general formula of CnH2nO2. This can either be an ester or a carboxylic acid. Let's look at the question, the thing. The options thereof. Ketone, no. Ketone has CnH2nO. Aldehyde, no, also have the same one. Alcohol, no. Alcohol has CnH2n plus 1OH. Carboxylic acid, very, very, very correct thereof. Which one of the following is an alkane? An alkane will have CnH2n plus 2, meaning if I have 6 of those, I need to double that. I need to double 6, which is 12 plus 2, it is 14. This is incorrect. If I have 6, it needs to be 14. If I have 6, it needs to be 14. So the most correct answer is C6H4. How interesting is that? Which formula shows the way in which atoms are bonded in a molecule does not show all the bond lines? Very, very interesting. We did this on a concept overview, not an empirical formula, not a molecular formula, but now it is what condensed. Why? Because structural now it is like this. It shows me the bond lines. Okay. Okay, yes, but this one, it tells me it is CH3, CH2, CH2, CH3. Can you see it? It shows the way in which atoms are bonded in a molecule, but does not show the bond lines. How interesting is that? Condensed. Nice, right? Consider the following compound. Let's try to name this. I'll name starting from where now my functional group gives me the lowest. Here it is 1, 2, 3, 4, 5. When I start on this side, it's going to be 1, 2, 3, 4, 5. Okay, can you see now the functional group has the same name, right? If now the functional group has the same name, I need to prioritize a branch. Which one is a branch? It is this one. Between 2 and 4, which one gives it the smallest number? It is 2. So it means I'll take the red one. How interesting is that? So it's going to be what? It's going to be 2-methyl 1, 2, 3, 4, 5 propan. Carbon number 3. Let me see, carbon number 3. What is happening here? Longest chain 1, 2, 3, 4, 5. Like that. Hana, prop it is 3. No, sorry, prop it is 3. Pent. 5 it is pent. Pentan. On carbon number 2, so on carbon number 3, I have a functional group. Therefore, it is 3, and it is what? It is a ketone. Why? Ketone has a double bond O between the carbons. 3 O. 3-methyl. No, 2-methyl pentan 3-one. Anything of some sort. 2-methyl pentan 3-one. Very, very here. Number A. The others are incorrect. Which one of the following terms describe hydrocarbons that contain only single bonds? This is a saturated for single. Saturated. Isomer ke eng? 55. For which one of the following molecular formula are chain isomer possible? Chain isomer is possible where? Okay, let's look at C4H10. C4H10, 1, 2, 3, 4. Is a chain isomer possible here? Yes. Why? Because I can say 1, 2, 3, and here and put a chain isomer. Okay, and put a branch instead of 4. So A is the most correct answer. Let's look at the others, why they are not. Let's look at others. C2H6, 1, 2, then H6O. This is an alcohol. Can I make a chain isomer of this? No, there are already 2. So they already have 2 carbons. Remember, chain isomer starts from 4. Chain isomer starts from 4. Okay? Why? Because if I have 3 like this, which one am I going to make a branch? Because when I make a branch here, it's going to be like this. Can you see when I remove this, when I make a branch, this is not a branch, it's still a longest chain. So just know that chain isomer starts from 4 carbons. So others with 3 carbons are not correct. Okay. Which one of the following represents straight chain isomer? Straight chain saturated hydrocarbons. Saturated for single. So this should be an alkane. And alkane has a formula, general formula CnH2n plus 2. So this one is wrong. C5H10, it is alkene. It has a general formula of CnH2. This one, C5H8, it is wrong. It has a general formula of alkyne, CnH2n minus 2, because when I double this, when I double 5, it is 10 minus 2, it is 8. Then here, number C, C6H12, this is also an alkene. This is the most correct answer thereof. Which one of the following is a secondary alcohol? Secondary alcohol, when I look at this, it tells me it is C again, and it is surrounded by three branches. That C is surrounded, remember a bracket means branch. By how many branches? 3. So it's going to be CH3 here, CH3 here, CH3 here. Then I have what? OH. This is the key. The carbon bonded to the OH is the key. It's bonded to how many? 1, 2, 3. So this is a tertiary. This is a what? A tertiary. Let's look at this one. Number B. Number B, the CH3, CH2. This one does not mean a branch. Why? It tells you there are CH2 that are following each other. A branch, it is CH3 inside the bracket. CH2 tells you it has CH3, okay? CH3 like that, CH2, how many of these? 3 of them, then OH. Therefore, can you see the carbon bonded to the hydroxyl group, which is the key, is also bonded to what? To one other carbon? No, this one is a single. It's a single. Look at number C, CH3, CH2, CH2, C, H, CHO. Okay, this is not even an alcohol. This is an aldehyde. This one, CH3, CH2, CH. Can you see CH, OH? So it means one it is H, one it is OH. Then I have CH3. So the carbon bonded to the hydroxyl group, it is bonded to one carbon and other carbon. Can you see? This is not directly linked to this one. So the most correct answer is D. Physical properties. A scientist now investigates a factor which influences the boiling point of alkanes. Boiling point of alkanes. Remember, alkanes are what? Are London forces. Alkanes are London forces. He determines the boiling point of first 6 straight chain straight chain alkane. Which one of the following is the independent variable? Remember, what is he changing, or the investigator changing? 6 straight chain isomer. So startile ka methyl, methane, ethane, propane, butane. So can you see what the investigator is doing is increasing the chain length. So now the independent factor is the chain length. Which one of the following has the highest boiling point? Highest boiling point. Remember, if they are all alkanes, can you see CH3? These are all alkanes, right? These are all alkanes. But now the one that will have the highest boiling point will have the highest intermolecular forces. So the one that is long, that has the longest chain. The longer the chain, the longer the boiling point, which is number D, because they are all alkanes. Which one of the following compounds has dipole-dipole forces between its molecule? Dipole-dipole forces are what? Ethanol. Yes. Ethane. No, ethane, it is London force. Ethene, London force. Ethine, London force. These are hydrocarbons. Remember, hydrocarbons are London forces. Which one of the following isomer has the lowest boiling point? The one that has the lowest boiling point, it is the one that has more branch. Okay? That has more branch. So when I check this one, it is 1, 2, 3, 4, 5, 6. So this one, it is this one is ethane. Okay? This one, it is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this one, it is 2-methyl. I'm saying ethane, hexane, I'm sorry. This one has a branch on carbon number 2. It is 2-methyl. Longest chain, it is 1, 2, 3, 4, 5. I do not count the one inside the bracket. So pentane. Here it is 1, 2, 3. On carbon number 3, it has 2 branches. So it is 2.2, so 3.3 dimethyl. Longest chain 1, 2, 3, or 1, 2, 3, 4. 4, it is butane. Okay. Then this one, it is 1, 2, 3. So I have 3 methyl. Longest chain, 1, 2, 3, 1, 2, 3, 4, 5, pentane. So which one has more branches? Which one has more branches? The one that has more branches, it is this one. So the more the branch, the more the surface area decreases. Therefore, if you increase the surface area, you decrease the intermolecular forces. B is the correct answer. Which one of the following compound has the highest vapor pressure? Highest vapor pressure means you need to have what? Lowest boiling point. Or you need to have what? Highest intermolecular forces. Okay. Now, which one is the highest intermolecular forces? Carboxylic acid. Which one is that? Oh, sorry, not highest, lowest. So it cannot be carboxylic acid because it has the highest vapor pressure. Okay. So boiling point. It can also not be alcohol. It also has a higher boiling point. This one, it is what? It is a aldehyde. This one, it is an aldehyde. This one, it is an alkane. Between an alkane and aldehyde, which one is a stronger dipole? This one, because this one is a what? Is a dipole. So which one has a stronger intermolecular forces? It is dipole here. So this one, it is also not the one. So the one that has the lowest intermolecular forces, which is alkane, which are London force, is the most correct answer. So the most correct answer in that particular method of it is D. Which one of the following compounds has hydrogen bonds between them? It can either be alcohol or carboxylic acid. So the answer is C, carboxylic acid. There is no alcohol. Which one of the following compounds has hydrogen bond between? I need to see a carbon that has OH. It should have an OH or a COOH. Can I see? No. This one, no, it is an ester. This one, it is a ketone. This one, it has an OH. It has hydrogen bond. It is alcohol. Which one of the following has the lowest boiling point? The lowest melting point, it should have what? London forces. The one that has London forces, it has the weakest. Which one is that? All of them, can you see a London forces here? But now it means if I want the lowest boiling point, it should have the shortest chain. The shortest chain, it is what? It is eth. Okay, it is ethane. It has the shortest chain. Remember, the longer the chain, the higher the melting point. The shorter the chain, the lower the melting point or boiling point. Which one of the following combination correctly indicates the strongest intermolecular forces found in ethanoic acid and methyl propanoate? This is an ester. An ester has what? Dipole. This is a what? This is a carboxylic acid. It has what? Hydrogen bonds. So hydrogen bonds for methyl propanoic, I need what? Dipole. So the most correct answer is number D. Very, very important and key. Now I move on to type of reaction. Consider this one. I have CH3, CH2, 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 CH3. This is cracking. This is cracking. Why? Because I cracked this one. This is type of elimination reaction. Okay? Elimination reaction. But now the product here, remember, it's either I form a what? An alkane plus an alkane. When I do cracking, I need to form an alkene or alkane, or an alkene plus H2. In this particular method of, I have what? CH3, CH2. So how many carbons here? 1, 2, 3. So here I have C3H6. But here I have what? 1, 2, 3, 4, 5. I have 5, which is C5H. This one will be C5H12. So now can you see how many I am short of? So that I balance the equation, I need other 2 carbons, which is C2. And now how many hydrogens do I need? I had 6 here. I need 6 to complete this one. So this is an alkane. So this will be named ethane. Which one is that? Ethane, ethane. So the most correct answer in that particular case thereof, it is number A. How interesting and beautiful is that? They say which one of the following organic reaction will take place only when exposed to light? Which one uses UV light? Okay, remember that one that uses UV light, it is what? It is what? A hydrogenation. Hydrogenation. But which hydrogenation? The hydrogenation that we find in what? In substitution. Okay, so this one, it is halogenation, no. This one, it is cracking. This one, it is what? But I said it is hydrogenation that we find in substitution. This one, can you see it is addition? They added here. So the most correct answer it is this one. Know your reaction condition very well. It is hydrogenation that we find in what? In substitution reaction. So here I substituted H, 1H with Cl. Then I get that. Very, very interesting. They say now the completion of combustion of ethane is represented by the ballast equation thereof. 2 of those 7, 4, 6. They say now the maximum volume of gas that can be produced by the combustion of 100 centimeter cubed of ethane. Ethane, remember this is in excess. So ethane, it is 100, okay, centimeter cubed. They say the maximum volume of gas that can be produced by the complete combustion of 100 centimeter, it is how much? Now let's see how much carbon dioxide can be formed. So you're gonna say the ratio, it is 1. So the ratio between C2H6 to CO2, it is 2:4, which is the same as 1:2. So it means for every 100 of this one, I need to produce double of that. So CO2 can produce, I can get 200. 200 watt centimeter cubed. But now if I'm talking about H2O, which is also a gas, the ratio of 2:3, which is 1:2. So 2:6, which is the same as 1:3. So it means if I have 100 here, it means now I need to have how much? 300 thereof. 300 centimeter cubed. So which one has the maximum? The maximum that we can produce it is what? 500 centimeter cubed. Which one is that? C is the most correct answer thereof. How interesting is that? So which one of the following represents a cracking? Remember a cracking, you need to start with what? An alkane. For cracking, you need to start with an alkane to form an what? An alkene plus an alkane, or to form an alkene to form an alkene plus an H2 between any of these. So let's see. This one, it is double bond, no. You need to be single, okay? This one is double bond, no. This one is alcohol, no. So we need an alkane. Can you see now? It forms now what? An alkane and alkene. And this is an alcohol, sorry. Alkane, again, it forms what? An alkane and what? An alkene. So the most correct answer is number C thereof. Very, very important and key. They say the type of reaction that takes place when a carboxylic acid and alcohol react is esterification. Remember, we are forming what? When we add this, we are forming what? An ester. Very, very easy marks. Very, very easy marks, this one. When ethane react with hydrogen gas, ethane, it is this. Ethane react with hydrogen gas in the presence of catalyst PT. It's a PT hydrogenation. Okay, it's a PT hydrogenation. What will happen? What will happen is that now we are going to form a single bond that has C. Can you see? That has like that. So it's going to form us what? Ethane. We're going to form what? Ethane. Why? Because an ethene, when we add that hydrogen, is going to be an addition reaction. Okay, remember unsaturated to saturated, it is an addition reaction. Okay. So you can also draw this and say it is like this: H, 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 H. When I add now H, H, it's going to be what? It's going to break this bond and form what? H there and H there. When I name this, it becomes an ethane. How interesting is that? Which one of the following rapidly decolorizes bromine water? This one is what we refer to as bromination. Okay, this one is what we refer to as bromination. This one, bromination, occurs when we have what? When we have hydrogenation. But what kind of hydrogenation? That occurs when we have what? Addition reaction. Which one of the following will rapidly decolorize bromine water? It needs to be an alkene. Whatever that we have, because it is an addition reaction, needs an alkene, not a carboxylic acid, not an ester, not an alkane, but now what? An addition reaction. An addition reaction occurs when we move from, remember, single and still searching, I went to USA and met a beautiful lady called USA. So, Sue. Okay. Therefore, if this is an addition reaction, I need to start with an unsaturated carbon. So, which is number A in that particular case, the of. Which functional group are involved in the formation of ester? Remember, ester is formed when we have what? Alcohol as well as what? COOH. It means now I need hydroxide ions as well as carboxyl. I get formyl, no. Hydroxyl and carboxyl, very, very good. Hydroxyl, yes. Carbonyl, no. Carbonyl, no. Hydroxyl and carboxyl. How interesting is that? Ester are formed by a reaction between two compounds, X and Y. Which one? Each with a different functional group. The functional group of this compound are, remember now, ester is formed between what? An alcohol and a what? A carboxylic acid. So we need a hydroxyl group as well as a what? As a carboxyl group. So hydroxyl group and carboxyl group, very, very good. Number A. This one, it is a carbonyl, wrong. This one, hydroxide ion, not ion. We do not deal with ions. Okay, yes. When butane is subjected to high temperature and pressure, this is cracking. I can see from their reaction a condition. The following takes place. Remember, when a cracking occurs, I need to form an what? An alkane plus an alkene, or an alkene plus H2. So now I have what? Butane, it is C4H10. So I have methane. Methane, it is CH4. Here, methane, CH4A. Now I need Y. Y should be what? Y should be what? How many carbons are left so that I balance? Can you say I have one there and initially I had 3? So it's going to be C3. H, how many H are left? I need 6. H6. Okay, which one is that? Which one is that? When I look at this, that has 3 carbons. 1, 2, 3. The number of hydrogen, it needs 6. No, these are 4 hydrogens. Sorry. Number B, I need 3 hydrogens. 3 carbons. 1, 2, 3. Good. Hydrogens, I need 6. 2 plus 1 plus 3, it is 6. Very, very correct. This one, CH3, CH2, CH2. No, this is an alkane. CH3, CH. How many carbons? 1, 2, 3, 4. No, I need 3 carbons. The B is most correct answer. When this one, an alkane which is unsaturated, is converted to a saturated, meaning the reaction will be addition. Remember, single and still searching, I went to USA and find a beautiful lady called Sue. Right? So if I move from unsaturated double bond to a saturated haloalkane, it is an addition reaction. But now I need to add what? I need to add what? H2, because this is an alkane. Okay, I need to add H2. The type of reaction that occurs, it is hydration. Not hydration. Not hydration. Why? Because I'm not adding water. It is hydrogenation. I'm adding hydrogen. The type of reaction, it is hydrogenation. Not hydrolysis, not hydration, not halogenation. It is hydrogenation. And it is a PT. It needs a PT. Which one of the following compound in solution will change color in bromothermal blue? Okay. A bromothermal blue, it is a reaction. Okay. A bromothermal blue, it is an indicator. Remember, Mary Baby Pack P. Okay, Mary Baby Pack P. Then bromothermal blue, remember baby. Okay, will change color. Will change color. So remember, an acid will change to yellow and base will change to blue. So an acid will change color in bromothermal blue. Which one is that? This one is not an acid. We need an acid. We need an acid. An acid, it is number B. Okay? The one that changes color, it is an acid, which is now what? Ethanoic acid or whatever a propanoic acid thereof. They say a test tube contains a liquid hydrocarbon. Okay. When bromine water Br2 is added to the test tube, the mixture decolorizes immediately. So that it decolorizes, we need what? We need a what? An unsaturated hydrocarbon. Then so that it becomes a saturated, then it is addition. Okay. When it decolorizes immediately, it means now we are adding a Br2 to the solution, meaning now I need to start from a what? From an alkene. Then and add what? Whatever that part. Br2. Then it forms me a what? It forms me an alkane. Okay, can you see? Remember single and still searching, I went to USA and find a beautiful lady called Sue. So if this is unsaturated and goes to saturated, it is an addition reaction. So which one is the correct answer? Okay, I need a what? An alkene. An alkene, it is this and this. In which type of reaction? Addition reaction. The most correct answer is number A. Every time when they say decolorizes what immediately, okay, also here decolorizes immediately bromine water. It needs to be an alkene moving to an alkane in a substitution reaction. Here, the type of organic compound formed when a haloalkane is heated in the presence of concentrated strong base. Now, haloalkane is formed in the presence of concentrated strong base. Remember a strong base? Concentrated. Oh, yes. A type of compound formed when a haloalkane is heated in the presence of concentrated strong base. Concentrated strong base, remember, it is the what? It is elimination reaction. It is a reaction condition for elimination reaction. That is specifically what? Dehydrohalogenation. And remember, in dehydrohalogenation, I'm trying to remove what? I'm trying to eliminate hydrogen and what? I'm trying to eliminate. So I have, let me show you like this. Cl, H, H, H. When in the presence of NaOH, what exactly am I forming? I want you to see this. Remember, it is elimination. I'm eliminating this and this. Okay, I'm gonna take this H is gonna come there and form what? Water. And this Cl is gonna come to that one and form me what? NaCl. But now, what is it that is left? What is left? It is an alkene. An alkene that has what? A C double bond C, like that. So I'm forming an what? An alkene. Can you see? I'm forming a what? An alkene. So the most correct answer is number B, thereof. Which one of the following it is hydrolysis? Remember, hydrolysis, it is when I move from what? From haloalkane. From haloalkane. In the presence of what? In the presence of H2SO4 to form what? To form alcohol. Okay, it can be H2SO4. Is it H2SO4? Or H2O? H2O. It can be H2SO4 or H2O. To form me what? It needs to form me alcohol plus HBr. Let's use wood. This is not hydration. Hydration occurs in addition reaction. This is substitution. So it needs to form me an alcohol as well as what? As HBr. Which one forms HBr? This one. So here is an alcohol, something OH and HBr. So A should be correct. This one forms forms a water. No. Remember, hydrolysis is only when you move from haloalkane to alcohol. When you move from alcohol to haloalkane, we do not have a name for that one. Okay, the most correct answer it is number A. So I hope you enjoyed the multiple choice questions that you'll be in a position of being exposed to. So if you enjoyed this video, thank you very much, and I hope you also enjoy others.